Good evening, everybody. So today we're going to be doing the next section in our book, which is 6.3, Solving Multi-Step Inequalities. And you'll see that what we learned previously is not going to change. We just do these the same way. They're just a little bit longer as far as solving for the dividing point. But other than that, it's the exact same process. So this is kind of one of the ones I'm saying where problems get harder, we do the same exact thing. So our first step, if we recall from before, is to look for a dot or a donut, and this one is going to be a donut because of the inequality symbol does not have the equal sign. So we're looking at this right here. That right there tells me it's going to be a donut because it does not have that equal to sign. And then we're going to solve it. And the very first thing we do to solve is we change to an equal sign. So I have 2x minus 3 equals 4. Please do not skip that step. I have a lot of kids who try and take shortcuts, who try and leave the inequality symbol in there. You'll see later in today's notes that there's even a time when we're going to put it back in, but you always want to change it to an equal sign to begin with. Okay, so 2x minus 3 equals 4. So that is going to then add 3 to both sides. So I get 2x equals 7, divide both sides by 2. So my dividing point, x, is equal to 7 halves. Okay, that's my dividing point. And now I need to graph it. So I'm going to put this on my graph. So I draw my line again. I don't care about how big my line is. All I care about is where is this dividing point compared to 0. So since this is a positive number right here, 7 halves, that means it needs to be to the right of 0. So that's 7 over 2. And what I'm going to put there is going to be a donut. So there I'm going to put an open circle, which is the donut. All right, now I need to test my point. So to test my point, I go back to the original inequality, and I plug in any number that I want that's not 7 over 2. Remember, you can't use a dividing point. So as I mentioned yesterday or the other day, I'm going to use 0 a lot. So I'm going to use 0, and so I'm going to say 2 times 0 minus 3, and now I must use the inequality symbol that I started with, so it's less than 4. Negative 3 is less than 4. That is a true statement, which means that the side that has 0 on it is true, which means the arrow is going to be going in that direction. Okay, so the arrow always goes toward the true side, and my last step is to write my actual answer, my inequality, the way that I like to do it. Under the arrow, I write x. Under the dividing point, I write my dividing number. If I do those two things, you have to do those two things, but if you do those two things, you always use the less than symbol. And it's not equal to because there was not an equal to symbol in my original, and it's also not a dot. Okay, so that's the first part. Now let's take a look at the next. Very similar, same type thing. It's a little bit harder problem, but I'm going to do the same steps. So my what we want to do here most likely is I'm going to use fraction busters. Now I'm going to show you the steps that I would expect to see. So what I'm going to do is I'm going to find a number that I can multiply that will get rid of it. Whoops. A number that I can use to get rid of my fractions. So I'm doing this. So I want to get both the 4 and the 5, so I think 20 would be a good number. And then I need to put the 20 on this side and the 20 on this side. There's still a few students who are confused when you put the 20 here and when you don't. If you are one of those students who's still a little confused on that, please come see me at office hours and I can explain it to you. All right, so 20 and 5 simplify out. That becomes a 4. 4 times 2 gives me 8x. 20 times 3 is 60. Now I need to make sure I change that inequality symbol into an equal sign. So there I go. And then 5 goes into 20. 4 goes into 20 5 times. 5 times 1x is 5x. And now I have x on both sides. So what I like to do is to get rid of my smaller x. So I'm going to subtract 5x from here, subtract 5x from here. I get 3x plus 60 is equal to, and please start getting used to writing this down, the number 0. Now I'm going to subtract 60 from both sides. So 3x is equal to negative 60. and then I divide both sides by 3. So x is equal to negative 20, and this is my dividing point. Okay, I just found my dividing point. So now I'm going to plot that onto my graph. Again, I don't care where it is on the line as long as it's to the correct side of 0. So that would be over here. I didn't check, but I need to make sure that I know now. I come back and look at this right here, and that tells me it's going to be a dot. So I put my dot in like that. And now I need to test 0, or I need to test a point, so I'm going to test 0. So here's a good example of when it's nice to use 0. So 2/5 times 0 plus 3 is greater than or equal to 1/4 times 0. So this, of course, is 0, so I get 3 is greater than or equal to 0, which that is true. 3 is greater than 0. That means this side is true, which means my arrow goes in that direction. And my last step is to write my inequality. So under the dividing point, I write negative 20. Under the arrow, I write x. If I do that, I always use the less than symbol, so it's less than. And since this is a dot, and since this is a sign right there, that means that I need to have the equal to sign there. Okay, so that's if you have to do fraction busters, all right? Now, on the next slide, you see that we have a new topic. So this should go on a new page. The first two problems, it's fine if you put them on the same page, but for this one, anytime I put a new topic at the top like this, I want you to put it on a new page. So the next 3 slides can all go on the same page because they all kind of go together. If you run out of room, of course, you can always use a new page. All right, so we're going to go ahead and solve this one. So the very first thing I would do is do 3x plus 5 and change that to equal sign. So it's equals, and then I need to distribute. So I get 3x plus 3. Okay, so now I have x on both sides, so I need to subtract both sides by 3x, excuse me. So on the right-hand side, I get 5, and on the left-hand side, I get 3. Now you might be going, shoot, what do I do now? How do I graph this because I don't have an x anywhere? And these are different type solutions. So at this point, what you want to do, I mentioned this before, is that once you get to this point here where you don't have a variable on either side. On the 2 previous problems, we had variables on the at least one of my sides of my equal sign. Here, this makes no sense. 5 is not equal to 3. So at this point, what I'm going to do is I'm going to go back to my original inequality and replace it with that right there. So I'm going to say 5 is less than 3. 5 is less than 3. I use the less than symbol because it's that symbol right there, so that symbol is the same as that one. 5 is less than 3 is not true. This is false, which means this problem has no solution. So if you look up here in my things, I have all real numbers, no solution, or 0. This is the one that has no solution. Okay? So if you get it to where 5 does not equal 3, that means there's no x value that makes this true. All right, now take the next slide. Again, for this one, looks like a very complicated problem, so we're going to start to simplify it as best we can. So I have x plus 6x plus 8 is equal to, make sure you change that to an equal sign, 9x minus 2x minus 3. Make sure you distribute that negative to both of those. Okay, so then on the left-hand side, I can now CLT. Remember, I want to CLT before I get rid of, I look at this as x on one side before I look at it as x on both sides. So I can combine these two right here and get 7x plus 8 is equal to, and combine those right there, and I get 7x minus 3. So now I can subtract 7x from both sides, and I get 8 equals negative 3. Once again, that's kind of weird, so we want to, say I don't understand that. How do I graph that? I don't have an x anywhere. So these are the ones where we're going to come back here and use that symbol and replace it with that symbol. So we're going to take this inequality and replace it here. So I get 8, and I use that same symbol that I used before. This one up here is the same symbol. and then negative 3. 8 is greater than negative 3. That is true, which means that my answer is all real numbers. What that means is if I were to graph this, so here's my 0, my arrow would go in both directions. It's all real numbers. Every x value that you plug in for this, right, these x's up here, will make the left side greater than the right side. It's all numbers are going to work. Okay, so that's that one. And the last one. Okay, so here we go. Again, looks a little bit complicated, so let's try and simplify it by things we know how to do. The first thing I always want to do if I can is distribute. So I have 7 plus 2x minus 4, and then I change that to an equal sign. Remember, every single time I change to an equal sign, I never leave it my original inequality. Trust me, you will make fewer mistakes if you do it that way. And then I have 3x plus 3. Okay, so now on this one, I have CLT on the left-hand side that I want to do. I want to combine this with this. So I end up with 2x plus 3 is equal to 3x plus 3. So then on the next step I'm going to do is I'm going to get rid of, now I have x on both sides, so I'm going to get rid of my smaller x. So I subtract 2x and I subtract 2x. So on the left-hand side I get 3, on the right-hand side I have x plus 3. And my last step is to subtract 3 from both sides, so I get 0 equals x. What I just found is, now this one's different than the last two because I have a variable on one side, so what I just found here is my dividing point. So, can I continue on? Do I just bring this symbol down? No, I don't bring that symbol down. Yes, I should continue on. So the next thing I'm going to do is graph my dividing point. So here, I start with 0 always, and on this one, my dividing point is 0. So I come back up here and I see that I'm going to be using a donut. So above here, I put a donut. Now, these are the ones that I mentioned in class that you cannot use 0 to plug in. You have to use something else. So I go back to my original inequality, which is 7 plus 2, and I'm going to use 1. So I'm going to use 1 here. 1 minus 2 is less than 3, and I apologize for how small this is. I'm going to say it out loud so you guys can write it. So this on the right-hand side here, this is 3 times 1 plus 1. All right, so you'll see when I simplify it, it works out. So this is 7 plus 2 times negative 1 is less than 3 times 2. This is 7 plus, back that up, 7 minus 2 is less than 6. 7 minus 2 is 5 is less than 6. That is true. 5 is less than 6. So that means that the side that has the 1 on it, so the 1 side is true, which means my arrow goes in that direction. The arrow always goes towards the true side. And for my final answer, I put 0, I put x under the arrow, and then I use the less than symbol. Okay, so there's my final answer. Just like that. Okay, so what I want to review real quick over here is I couldn't use 0 to plug in for my x. Whoops, I couldn't use 0 to plug in for my x. I had to use another number. I could have used any number that I wanted. I used 1. I could have used negative 1, or I could have used 5, or whatever. I chose 1, and then I worked the problem out. So 1 minus 2 gives me negative 1. So I still had 7 times 2, or 7 plus 2 times negative 1. Over here, I had 3 times 1 plus 1, which is 3 times 2. On the left-hand side, 2 times negative 1 gives me negative 2, so I have 7 minus 2 is less than 6. 7 minus 2 is 5. 5 is less than 6. That is true, which means the right side of my dividing point is true, which means my arrow should be going to the right. Okay? All right, so those are the notes for 6.3. And have a great weekend, and I will see you guys. Oh, no, it's only going to be Thursday now. See you guys Friday. All right, see you later. Bye-bye.